A cargo ship fitted with a cutting-edge, computer-controlled smart sail is currently undergoing sea trials off the coast of the United Kingdom. The Pacific Grebe, a large nuclear fuel and waste carrier, is over 100 meters, 328 feet, in length and weighs nearly 5,000 tons. Despite its massive size, this ship is now testing how effectively it can use innovative sail technology to help reduce fuel consumption and lower emissions during its voyage. The Smart Sail, part of Smart Green Shipping's FastRig wing sail technology, represents a major leap forward in maritime propulsion.
So this project's all about demonstrating wing sail technology on a ship. So we've used wind for thousands of years to propel our ships around the oceans, but what we're trying to do now is use the most modern, efficient, kind of rigid wing sail technology to generate thrust that pushes the ship forward. That will reduce the amount of thrust that the propellers generate, that reduces the engine load, you reduce your fuel consumption and emissions. So we can make maritime ships, maritime engineering greener and reduce the cost of fuel.
Traditional sails have been used for thousands of years to harness the wind's power and propel ships across the oceans. However, the FastRig sail is designed to take full advantage of modern engineering. Unlike the traditional mast, boom, and sail seen on yachts, the FastRig wing sail is more akin to the wing of an aircraft, with a rigid design optimized to generate thrust.
Accounts for about 3% of global CO2 emissions, which isn't bad considering we transport almost everything we use by sea, but we've got to find ways of reducing that in the future. So by 2050, shipping needs to be net zero. So we need to find ways of reducing the fuel and the emissions from shipping. And wind is a brilliant way of starting that process because we can install technology like these wing sails onto existing ships. So we don't have to redesign ships from scratch. We can take existing ships, retrofit these technologies to them, and that will reduce their emissions quickly. So we can do this in a matter of years, while we wait for what future fuels will come along which allow us to reach our net zero goals.
The FastRig test sail, developed by Smart Green Shipping, weighs 20 tons and stands 20 meters, 66 feet, tall. The production units, however, will be taller, measuring up to 34 meters, 112 feet. What makes this sail so advanced is its automated system.
It's more like an America's Cup yacht wing, but it's automated, it's intelligent, so it will stand up and it'll turn and it'll open according to the wind conditions which it knows. So it's got sensors on it, so it'll say, oh, the wind's coming from that direction. The best way for me to position to position myself is to go over there. So if the wind is too high, it will lie down. If the wind is too low and creates resistance, it'll lie down. If it needs to come in a port, if it needs to come out of port. So it's retractable for those reasons. So it's designed to have the minimal amount of sailing knowledge from the crew.
Using sophisticated sensors and artificial intelligence, the sail can detect wind conditions and adjust its angle automatically, positioning itself in the most optimal direction to maximize efficiency. This process is automated and does not require any complex sailing knowledge from the crew. The sail is designed to raise and lower itself within 15 minutes at the push of a button. One of the most significant advantages of the FastRig wing sail is its ability to reduce fuel consumption and emissions.
The market is very interested in wind. There's lots and lots of regulation coming at shipping about it reducing emissions, and the prevailing thought is that we're going to find some alternative fuel, and there will be an alternative fuel, and that'll be great, but it'll be much more expensive and it'll be much less energy dense than fossil fuel, and it's decades away. So what can we do now? How can we reduce the amount of fuel that's going to be used? You can use wind, and you can use wind now, and it's becoming increasingly popular amongst shipping community, but they need to understand, how does it work? Can you put it on my ship? Does it break my ship? How does the crew operate it? How much is it going to cost me? How much is it going to save me? And that's what this test is all about, proving those different pieces of quite legitimate anxieties that the ship owning community has.
By using wind power as a supplementary energy source, the ship can decrease its reliance on traditional fossil fuels. This, in turn, helps to reduce carbon dioxide, CO2, emissions and lower fuel costs, critical factors for the maritime industry, which is under increasing pressure to adopt more environmentally friendly technologies. The trials taking place with the Pacific Grebe are an essential step in proving the effectiveness of this technology. The key aspect of these sea trials is comparing the performance of the vessel both with and without the FastRig sail under the same conditions. This allows engineers and researchers to measure the impact of the sail on the ship's speed and power output. The results from these tests will provide valuable data to confirm whether the wing sail can live up to the performance predictions made by smart green shipping. The project has attracted attention from both the maritime industry and investors, as successful implementation of autonomous sails could have far-reaching consequences.
So shipping, so the key thing for this project, so the University of Southampton is involved in the project to predict the performance of this ship. So we're predicting the fuel savings, but the crucial thing about this project is we're then doing structured sea trials with the vessel. That allows us to test the performance of the ship with and without the wing in the same conditions and measure the change in the speed of the ship and the change of the power on the shafts. So that allows us to verify our performance predictions, and that gives the industry confidence that our predictions are correct, and it allows investors to have confidence to invest in this technology going forward.
If proven effective, retrofitting commercial ships with these state-of-the-art sails could significantly reduce operating costs, improve fuel efficiency, and contribute to global sustainability goals. The UK government, in fact, has estimated that up to 40,000 ships, especially tankers and bulk carriers, could potentially benefit from wind power integration. These ships, which often operate away from public view, are responsible for transporting critical materials such as metals, grains, and building supplies across the world. As the global shipping industry continues to grow, the demand for cleaner, more cost-efficient solutions is becoming increasingly urgent. The success of smart green shipping's FastRig wing sail technology could pave the way for widespread adoption of wind-powered shipping. By blending traditional principles with cutting-edge automation and intelligent systems, the maritime industry could enter a new era of sustainability, helping to reduce its environmental footprint while improving operational efficiency. The ongoing trials with the Pacific Grebe represent just the beginning. If these technologies are proven viable, it could be a game-changer for the maritime sector, helping to make the shipping industry more eco-friendly, efficient, and cost-effective for decades to come. The successful implementation of wing sail technology could also drive the maritime sector closer to achieving its sustainability targets. The International Maritime Organization, IMO, has set ambitious goals to reduce greenhouse gas emissions from international shipping by at least 50% by 2050.